Alright, so today it's day 21 and I finished the GPT tokenizer. I mean, not exactly that one, but a generalized version, and we constructed it like layer by layer. The first step was implementing the main algorithm, which is the BPE, the byte pair encoding algorithm, which in essence has two distinct layers. The first one was to count the most frequent pair. So basically what we do is we identify the bigrams, we count the most frequent bigram, and then we merge them iteratively. And we get like an encoded list of integers that represents the original sentence. That's it. But the list is not the important feature here, but rather the tokens, like the dictionary of the tokens that you merge. Which in this case, for example, okay, as a quick example, we can have a text, right? We pass the function to create the BPE, and we realized that this pair repeats a lot, so we're gonna merge it into another character, and because it's by bytes, we have 256 different characters starting from zero, so you add a new one that replaces this pair. So in this way we compress the original sentence by having a longer list of vocabulary. And yeah, that's it. And now when I implemented this a bit more formal, we have not only to encode the function, a sentence, but also to decode. So for the encoding, I mean, it's just a simple function. We take the bytes. Okay, first we need to create the dictionary, right? This is the dictionary, and we map like all IDs to the corresponding bytes. And we basically know that we only have, because we are using where you are 2 to the 8, 4, 16, 64, 20, 28, 50. Yeah, basically, because we are using UTF-8, we know that we have 256, right? So we can map those characters, and we already know, for example, that there are specific bytes. For example, if I take the dictionary, if I take the dictionary and see what is the, but I have to run it again. If I take the dictionary and see what byte it's mapped when I have the number 97, we can see that it's the letter A. And we can encode the sequence. So basically, if I have a sequence like hello or like art, right? This one, it's gonna be 3 bytes. The byte corresponding to A, the byte corresponding to R, and the byte corresponding to T, right? So this is the encoding of the sequence. And basically intuition is that we can have this more robust because we can have characters that by in Unicode integer have occupy more than 2 bytes. So in this way we can comply to unknown characters, right? And the way, like, to formalize this idea, it's to first build the vocabulary, and to build the vocabulary we have to do this. This is the vocabulary of what we already know, which is the bytes, and then we extend this vocabulary over the merges, right? And we are gonna add it. So the merges, it's gonna be the dictionary, it's gonna be like this object, and if we are basically mapping a pair into an integer. So this has a byte representation, and if we concatenate concatenate these bytes, we can save like this mapping into the dictionary mapping of all the vocabulary. That's what we're doing. And we do this like for every character in the string, right? Because we need to join all different mappings, right? And yeah, that's it. That's basically to make the decoding. And then we apply this like another function to do the encoding, which in essence it's like you're gonna have the hello world, you want to do the mapping, we know that we need two functions, we can have stats and merge, but this encoding is different from the encoding above, because in the encoding above it's training the algorithm to have this dictionary that will map the tokens, and in this one we already have the dictionary, so we can directly map it. Like we don't need to compute the frequency. I mean I'm using this function, but I'm using it to know which pairs can I actually merge in the sentence. So if I have hello world and I'm gonna encode, that means I'm gonna transform this into a list of integers. I have to convert this into UTF-8, into a list of bytes, and then I need those bytes to merge them according to a rule. So if I can merge them, that means that the length is greater than 2. I have at least a pair. I'm gonna get like the list of all different pairs, and I'm gonna get the pair that I should merge first, and that is gonna be this one, because that's how we train the tokenizer to work with. I'm gonna start by merging first 101 and 32, this pair, and mapping it into 256. So we can use this function, right? That it's when you take the minimum, when you query this dictionary of this, which is gonna be this value, over stats, which is gonna be like opposite pairs that exist in your text, and you have to handle like what happens if like there is like the pair that you want to merge is not in merge, like all the pairs does not exist here. I mean, there's like it's the same case, you don't need to merge and you can break. That's it. This is the decoder, and then we explore a little bit more about the actual implementation, how ChatGPT does it. And basically they don't iterate over like infinite long sequences, but rather over kind of words, and they do like a pre-processing doing by using regular expressions. And this is like one of the GPT the one that is implemented in the code. Obviously they change it later when they use ChatGPT 4, but this one was like the initial one, and we have like some sort of fixed way of separating the words. For example, we have these ors that are like different rules that you're gonna have these separations if you start with this, or if you start with this, or if it's a letter, right, or if it's a number, etc., etc., or if it's a space but it doesn't, you're not gonna take the space. There are like many reasons like why this is the way it is. And then what you do after you have these sequences is that you perform the training over the possibilities pairings for each like word. And we have an example of using the tick token, which is like an actual modern tokenizer. And actually I also try sentence piece, and it is really messy, but it's another form of tokenizer. And that's basically it. I'm gonna tomorrow implement now GPT from scratch, GPT-2 from scratch, and that's it.